Maybe. Okay, so quadratic equations of this form. So they cannot have a b term. Ax squared minus c equals 0. These are the forms of equations that will work. Yes? Okay, again, it has no bx term, no b term, whatever. Okay, and it can also be written ax squared equals c, or even x plus or minus a number squared equals c. So any of those methods will work here. Yes? Methods. Any of those forms will work, not methods. Okay, so there's 3 steps. The first is to isolate what's squared. So looking at this example, do y'all see how I have x squared? Okay, is it by itself on the left side of the equal sign? No, what does it have with it? Negative 49. How do I get rid of negative 49? Yeah, so I'm going to add 49 to both sides. And I get x squared equals 49. Everybody okay with that? Okay, so knowing that, that's my first step. So now my second step says take the square root of both sides. So when it's alone, I can square root both sides. And remember, we said the square root cancels the squared, so we get x equals. Now this is the weird part. Anytime you take the square root of a number, it's going to be a positive and a negative answer when you're solving. And the reason being is, what's negative 7 squared? 49. And what's positive 7 squared? So could both of those give you this? That's why anytime we take the square root, we're going to put a positive and a negative. And if I type the square root of 49 here, does it give me 7? Yes, so that's why this is this. However, because I have 2 answers, I have to separate. So my answer is negative 7 comma positive 7. Any questions with that? Okay, so knowing that, let's look at number 1. Okay, so again, is what's squared alone? Yes, bless you. What's squared is alone. So when it's alone, what's my second step? Square root both sides. So I'm going to square root. And I want you to realize on the left, the square root cancels the squared, bless you. And I'm left with x equals, and again, it's going to be a positive and a negative every single time when I'm solving. What's the square root of 100? Check it in your calculator. 10. So my answer is negative 10 comma 10. Okay, look at number 2. Is what's squared alone? No. How would I get x squared alone? What do I need to get rid of? How do I get rid of that 5? I'm going to divide, because isn't this multiplying if there's no symbol? What's the opposite of multiplication? Division. So we're going to divide both sides by 5. And I get x squared equals what? 12. Now is what's squared alone. So what's my next step? Square root both sides. So square root cancels the squared, and I get x equals plus or minus. Is the square root of 12 a perfect number? No, because watch, if I type it in, I get a decimal. So that's when I know that I have to come over here and do my factor tree. So does 2 go into 12? Yeah, this is a simpler one. 6 times. Does 2 go into 6? 3 times. Is 3 prime? So here's my pair, and here's my leftover. So what number do I get to take out? 2. And what number goes back in the house? 3. So my answer is negative 2 square root 3, positive 2 square root 3. Do y'all kind of see the difference on when you have to do the breakdown and when you don't? So remember, if we typed the square root of 100 here, it gave us a whole number of 10. That's why we didn't have to do the factor tree, right? Here, it gave me a number that gave me a big decimal, so I had to do the factor tree. Yes? Okay, I'm going to let y'all. Okay, first things first on number 3 is what's squared alone. No, what do I need to move? The -5. How do I move a -5? So I'm going to add 5 to both sides. And I get x squared equals what? 1. Now that my x squared's alone, what do we do next? Square root both sides. So square root cancels the squared. And we're left with a positive and a negative. What's the square root of 1? 1. So my answer is -1, 1. Mm-hmm. Okay, look at number 4. I want y'all to get x squared alone on number 4. Okay, y'all should be getting x squared alone on number 4. What do I need to move? The 25. How do I move a plus 25? Minus 25. So I'm going to subtract 25 from both sides. And I get x squared equals -25. Now, what I want y'all to realize here is if we check this, what does it say? Undefined, because next would be the square root both sides, but you cannot take the square root of a negative. So we don't write undefined. We're going to actually check our work. So we're going to check the equation that we were originally given. So x squared plus 25. And remember, we're solving for x-intercepts. Does this ever touch the x-axis? No. So what's my answer? 0. No solution, not 0. And I'm going to show you why. It's not 0 because 0 means that it's this and it touches once at 0. Does that make sense? Yeah. So this is no solution, not 0. Any questions with that? Anytime you take the square root of a negative, it's probably going to be no solution. Always check your work. Yeah? Okay. So let's look at number 5. I want y'all to try to get what's squared alone first. What do you need to move first? Yes. Mhm. You're getting it by itself right now, by yourself, yes. Not right this second. Okay, so what do we do first? How? So plus 108 to both sides. And I get 3x squared equals 108. Is what's squared alone? No, what do I still need to get rid of? Yeah, I'm going to divide the 3 because I still have to get rid of that 3. And then 108 divide 3 is 36. So now what do I do? No. Square root. So square root cancels my squared, and I get x equals plus or minus something. So remember, we always check it in the calculator first. And what's my answer? Positive and -6, right? So we have -6, comma 6. Okay, so I want y'all to try number 6. Everybody should be trying number 6. What do we do first? Yes, I have to add 16 to both sides. And what's 59 plus 16? Huh? 75. Okay, is 75 a perfect square? Did anybody check it? Because next thing we should do is square root both sides. Square root cancels the squared, so we get x equals positive and negative. But 75 is not a perfect square if we check it. So we have to start by breaking it down. So does 2 go into 75? No. Does 3? Yes, so 3, 25 times. Does 3 go into 25? No. What goes into 25? 5 and 5. So I have a pair of 5s and a 3 left over. So what do I get to take out? The 5. And what goes back in the house? The 3. Now we're not done because we just have to separate it. So I have negative 5 square root 3 and then positive 5 square root 3. Any questions with that? Okay, flip it to the back. Okay, so first things first, looking at this one, is what's squared alone? No. So what do I need to do? Divide both sides by 25. And I want you to realize that if we divide both sides, we get this, and we don't want decimals, we want fractions. So does it simplify? No. Do you see how it's the exact same thing? So we're just going to leave it. Well, our calculator is still going to do the work for us because we're going to square root both sides. And we're going to check our work. So square root cancels the squared. We get x equals positive and negative something. So I'm going to check before I try to do it by hand. And I want you to realize it gives me a decimal again, but it gives me the option to turn it into a fraction. Is that fraction work? Yes. If it gives you a pretty fraction, you can use it. So there's my answer. Now, what I want you to notice is that this won't work if it won't give you a pretty fraction. Because watch, if I type this, do you see how it no longer gives me the option to type or turn it into a fraction? It's because it's no longer a perfect square over a perfect square. So just know that it won't work if we're not allowed to use that. Does that make sense? So I want y'all to try number 8. Yeah, you gotta try something. Oh, yeah. Okay, when you finish, I want you to check your work with the board. Any questions with that one? You type in your calculator, just like we did the last one. So you'll type 49 over 121, turn it into a fraction. Yeah, you have to square root it. Your answer, when it looks like this, will never be the same thing without the house. It has to change. The only one that's going to look the same is 1. Okay, what do you notice is different about number 9? There's parentheses, okay? And it still works because remember, our first step was to isolate the square. Well, isn't this whole thing squared? So is that whole thing already alone? Yeah, so then I'm ready to just square root both sides. So again, the square root cancels the squared. And we have x plus 1 equals positive or negative something. Well, what's the square root of 16? 4. No. We already took the square root. Now, because I have 2 answers and I don't have an x by itself, I'm going to have to separate before I solve. So x plus 1 equals negative 4. X plus 1 equals positive 4. Now can I solve for x? Yeah, how do I get rid of a plus 1? Positive 3, sorry. Okay, so I want y'all to start number 10. So right away, do we get to take the square root of both sides? Yeah, because what's squared is already alone. Square root cancels the squared, and I get x minus 9 equals positive and negative something. Well, if you type the square root of 11, what does it give you? Yeah, an ugly decimal, okay, doesn't work. So we'd have to break it down. But here's my question. Isn't 11 prime? So can it even break down? So then there's nothing to simplify. Now, this is the weird part. So again, because x isn't by itself, we're going to have to separate. So we have x minus 9 equals negative square root of 11. And then x minus 9 equals positive square root of 11. Somebody has to go before you, so I'm going to add 9 to both sides. Now, are these like terms? So radicals are like letters, and you cannot combine them unless they both have the same radical. So you're not going to combine this unless this was 9 square root of 11, then it would be the same. Yes? Okay, so knowing that I have 9 minus the square root of 11, and then I have 9 plus the square root of 11. And remember, you can also write answers like this. Mia, you can go. Okay, what's the difference with number 11 through 14? Yeah, there's just something outside the parentheses. There's a plus, there's a minus, there's division, so on and so forth. Okay, the only difference, now they're like just like the ones on the front where we had to get what's squared alone. It's the same concept. We just have to get what's squared alone. So let's do number 12. Okay, so this is what's squared. Now, you cannot distribute the 3 in because if we do order of operations, what comes first, exponents or multiplication? Exponents. So because I didn't get rid of the exponent, you cannot multiply the 3 inside. Does that make sense? So how else can I get rid of the 3? Well, isn't this multiplication? Yeah, so I'm just going to divide both sides by 3. So we get x minus 2 squared equals, what is that, 8? Now is what's squared alone. Yes, so now we can take the square root of both sides. Square root cancels the squared, and we get x minus 2 equals positive and negative something. Now, if I type the square root of 8, is it a perfect square? No, so what do I have to do? We have to do the factor tree. 2 and 4, 2 and 2, and then we're done. Lots of 2's here. We do have a pair of 2's, and then we have a leftover 2. The 4 we broke up, so we're not looking at that number anymore. Does that make sense? Yeah. We only look at the numbers at the bottom of the triangles. Okay, so knowing that we have a pair of 2's, so we get to take a 2 out, and then we have a leftover 2, so we have to put a 2 back in. Last step. My country accent was coming out. Last step, what do we do? So looking here, from here to here, what did we do? We separate and solve. So separate x minus 2 equals negative 2 root 2. X minus 2 equals positive 2 root 2. So add 2, add 2. Lots of 2's. Okay, one more we're doing together, and then y'all are going to work on them the rest by yourself. So look at 14. I'm not even going to go all the way. What do you have to get rid of first on number 14 to get what's squared alone? The 4. So we have to get rid of plus and minus first, and then we divide, okay? So how do I get rid of a plus 4? And then I'm left with 2 parentheses x minus 3 squared equals, that gives me 72. Now what? Divide both sides by 2. Okay, I want y'all to finish that on your own.